like to talk a little bit about consistency so I understand it. It seems consistency is a concrete example of an abstract principle. Is that correct?
The model is an example of the abstract principle. And consistency, okay, so you have an abstract idea. A Cocker Spaniel with a toaster head. Okay. And you go, does that make any sense? And no, it doesn't. I've never seen one. But if somebody brought one in, then you'd go, oh, I was mistaken. So in mathematics, it's very difficult to prove that something doesn't exist or is not consistent. Well, okay, to prove something doesn't exist is very difficult. To prove something exists, you just have to show it. You know, if somebody brings in this Cocker Spaniel, you go, oh yeah, there it is. But to show that nowhere in the world or in the universe there is such a thing, that's hard. Mathematicians can find ways to do that. To show something is not consistent is pretty, relatively easy. If I have a theory that, oh, I don't want to give any examples. I'm going to get wound up in details. But if I give a theory that describes numbers, for example, and somebody comes along with a number that shows that my things are inconsistent, like, well, if I say 1 is greater than 2, and if I say 2 is greater than 0, then all of a sudden 1 is greater than 0, and it's not consistent. To prove that it is consistent is harder. And the way mathematicians do it is not from within the theory itself. So in other words, you don't take the axiom and prove and prove and prove that it's consistent. You can't prove that it's consistent using its own terminology. What you do is find a model, and if the model is consistent, and Jane sees a flower and John sees a flower, and they look at each other and they look at the flower and they talk about the flower, you know, yeah, we've got that experience. That's a consistent model. Now, to use his axioms to describe or to use consciousness as a model, you know, you're running up against philosophers. You know, philosophers are busy saying, well, we don't really know if consciousness exists, but everybody's going to exist. A person named Jane and a person named John could exist. So, you know, that's the idea, that if you have a model, it's consistent.
So then a model is a concrete example of that relationship that you can look at.
Yeah.
How would this relate with counterfactuals in science, where you have your hypothesis and you're looking for one point that's different? Is that the same idea?
Yeah, exactly. And so you have a theory that meditators have certain kind of brain waves. Okay, so your theory is that meditators have these beautiful brain waves, and then some faculty wanders in and you do their brain waves, and they're just completely different, and you go, oh, my theory's wrong. And that's why to do science, you need to base your hypothesis on good experience, not just, oh, maybe meditators can, I don't know, do something. And I mean, this is the reason why the scientific research on transcendental meditation has been so universally successful, is because meditators go, oh yeah, my mind is clearer, or oh yeah, my attention span is longer, or oh yeah, I am healthier. And so they can do the test. But let's try to think of an experiment that probably wouldn't work. If you say, oh, meditators, my friends all seem to be able to read my mind. must be meditators can read people's minds. Well, you start studying that, and I'm not sure you'd get very good results, see? So, and with the consistency, like if in that model, Jane sees the flower and John sees Jane, and Jane hears John, and John remembers Jane seeing the flower, and all of those things, if you came up with something that was inconsistent, like the Cocker Spaniel with the toaster oven head, you'd go, oh, well, I don't think this is a good model. And that's the value of using a simple model, is because you feel like you know everything about people looking at flowers, you know, in that way.
And so the model could be applicable at different levels. So we have Jane and we have and the flower and so on. But of more fundamental levels, we have just awareness itself, awake to itself. So it's that same pattern we're seeing expressed throughout life.
Yeah, yeah.
So it seems to be making a statement that what is expressed at all different levels are similar patterns, but they're expressed in different ways because of the layers being expressed.
And that's what makes mathematics so powerful. You develop a theory, a group theory. It's about symmetry. You can use that to create symmetric patterns. You can use it to study crystals. You can use it to study strings. You can use it to study anything that's symmetric. So you develop one theory. Or differential equations. There's some differential equations like that describe waves, and you can use them for water waves, air waves, waves that go through the interior of the earth, the solar wind you can use them for. You can use them for Schrodinger's theories. So if you have a theory, and this is why mathematicians try to consolidate theories. If you have a theory like this and a theory like this and a theory like this, and you can consolidate it, you get a more inclusive, more abstract theory, and it can be applied to everything that this and this and this could have been applied to. So, and it's an organic thing. It's not like you sit down and say, well, how can I get a good abstract theory? The process is more like, well, I'm thinking of symmetry groups right now. Well, I have equations and they have roots. And it's really interesting that roots seem to come in an orderly way. How can I understand the orderliness of the roots of an equation? And then you go, oh my God, that's how I can understand the structure of a crystal. That's how I can understand strings. So it's by steps. It's always by steps like that. And as we know that when we look at things, we are spontaneously drawn in the direction of greater charm, and that's in the direction of pure consciousness. And so mathematicians, when they say, oh, that's a beautiful theorem, and they say that, we do that all the time, don't we, Ann? Whenever we say, oh, that's a beautiful theorem, why is it beautiful? It's because it's more charming, it's more abstract, it's more unifying, it's more concise, it connects more different ideas. So there we go.
Thank you. Other questions?